Okay, so one of them is just dropped. One of them is shot straight out exactly horizontally, right? The question is, of course, which one lands first, or do they land at the same time? Or what was the question? And I know some of you probably saw this on like Mr. Wizard, and you know what the answer is because Mr. Wizard told you or something like that, you know, or Bill Nye the Science Guy, or I don't know who did, right? Okay, but do we have any? Because this is not like history class where we could debate the cause of the American Civil War till we're blue in the face, and some people can differ in opinion. There is a correct answer here. I'm not very smart, so that's why I'm teaching physics. I couldn't teach something like that where it'd be like, it's way too much critical thinking for me, right? What I'm doing right now is I'm just checking. I'm using a very sophisticated method here to make sure that these two spheres are level. They look level. I'm lining them up with the cabinets in the back of the room. That's good, isn't it? Yeah, there we go. Now, what's going to happen here is I'm going to click this switch, and this thing is going to become a magnet, and it's going to shoot this way. It's going to get sucked inside that magnet. It's the same little device that actually opens and closes your car doors when you like lock them, unlock them. There's a solenoid that's going ka-chunk or ka-chunk, like that, right? And it's going to go ka-chunk this way. This ball is going to fly this way because it's going to get propelled that way. This ball is going to have the pin pulled out of it. It's going to drop straight down. And we do have super slow-mo, so we're going to analyze this in super slow-mo, but what we're going to do when we do it in real time is we're going to listen for the clicking sound, right? It's either going to go click, click, or click, click, or it's going to go click, yeah? It's either going to go click, click, or click, click, or it's going to go click. We're going to do what the first base umpire does, right? They listen for two sounds. If the ball hits the glove before the foot hits the bag, they're out. And then if it's the other way around, they're safe. What if it's the same time? Are they safe? Tie goes to the runner? Not anymore? Yeah, I don't even know. Somebody said that, and I was like, no, it always does. Are we ready for this? Is the world ready? Okay, here we go. Let's clear all this stuff out of the way. Okay. Okay. What did we hear? Yeah, I heard just one click. That was amazing. Now, since this costs $17.64 when the school is opened, let's do that one more time, just because it's so much fun. Hey, where's the hole now? There it is. Okay, is it still level? Yeah, more or less. Let's go. Yeah, it's just about to the limit of my ability to hear the difference. It's the same. So now let's watch it in super slow-mo. Okay? Super slow-mo. Rewind, play. So you can see at any given instant in super slow-mo, right, that they both, neither in the vertical direction, neither of them had velocity, correct? Okay, so they started from rest vertically anyway. So that means at any given instant they've been falling for the same amount of time. The only difference is this one's moving sideways, right? At any given instant in time, they're the same height off the table. And so that's why. Anyway, that's why they hit at the same time. Okay, so this is a very important principle of projectile motion. This is very good news for us. Okay, the principle is this. The principle is that horizontal motion does not affect vertical motion. Horizontal motion does not affect vertical motion, and vice versa. Okay? Horizontal motion does not affect vertical motion. There is no effect. Okay? And I'm trying to give you a little English language lesson here because I get people that write papers about this affects this, right? If it's a verb in science, if it's a verb, it's almost always A-F-F-E-C-T. How does that affect you, right? And if it's a noun, like what is the effect of mass, increased mass on trebuchet velocity? Then the noun is always EFFECT. There are exceptions to both of these things, but they are rarely encountered in science, okay? So this is a very important principle, and then notice how the principle is PLE. I'm not saying that Darren Barnard is not an important principle, but he's a PAL, right? That's the one that can be your pal. Huh? Yeah, that's how I remember it, because I'm not really that great a speller. Actually, I'm good at spelling words, except for I cannot spell opportunity. Can't do it. Tried. You know. Okay, so our next demonstration. Are you ready for this? Here I have, and maybe you have one of these at home too. Here I have a cart. Whoops. And the way this cart works is, shut up, quite simple. Okay? There's a pin on this, and if I hold it still and I pull the pin out, there's a little marble gun, and it's going to shoot the marble straight up in the air. The marble goes up, it goes down, nothing very exciting there, and lands back in the cart. Yes? Notice it's a cart. It can roll. Notice the pin is attached to a string. Notice that I can give this thing a shove, and when it reaches the end of that string, if I shove it straight, if the cart actually rolls straight, let's just double check this. Okay? Yeah, it's straight enough. It's kind of, I'm a little worried about it. It's a little bit crooked, but I don't know if I have time to fix it now. Okay? If I give this a shove, it's going to reach the end of the string, and the ball is going to pop out. Now, the ball is either going to land behind the cart, before the cart, or in the cart, right? It's either going to land before the cart, in the cart, behind the cart. Yeah? Before the cart, in the cart, behind the cart. What do you guys think? How many say it's going to go before the cart? You're a cart before the cart kind of person. How many votes we got for that? We got 2 votes. How many say in the cart? Raise your hand if you think it's going to land back in the cart. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 17. Okay. How many say behind the cart? 1, 2, 3, 4, 5, 6, 7. Okay. There's enough. There's enough here to be a controversy. But I think it was clearly a victory for in the cart, wasn't it? I think definitely. I think if it was, even in Florida, that was a majority, wasn't it? Right? Okay. So I don't even think we need to try it. Should we try it? Yeah. Oh, okay. Oh, fine. If you insist. Here we go. All right. Drum roll, please. Woo! Here we go. Now, would somebody like to use the very important principle that we just learned to explain why it landed back in the cart? So, you're just restating it. So explain why in this case that allowed the thing to land back in the cart. Ryan's got something. They're both traveling at the same speed. Both the ball and the cart have the same horizontal velocity. Is that what you're saying? Yeah, there we go. So the fact that it's shot in the air, Max.
Oh, I was going to say, since it was shot up, it kept the same forward velocity, and that's why it shows the current impact.
Right. The fact that it's shot up in the air, right, means that that doesn't affect its horizontal velocity. Right? So therefore, it's got the same horizontal velocity, and it's going to stay directly above that. In fact, if you were a little ant riding along on the edge of this thing, somewhat dangerously, right, and you saw the ball going up in the air and coming down, would it look different if it was moving?